I'll be reviewing my final project for ISE 535. So the outline for this video, first I will review the problem statement, what I was trying to accomplish with this project. Second, we'll go through the 4 different learning criteria and how that project accomplishes each one. And finally, we'll go through a live demonstration showing the feature set. So the problem statement for this project is I created an MRP system in Python, and it contains functions related to planning, ordering, and material availability for inventory. So the 4 learning criteria, the first was accomplished through CSV files and a Postgres SQL database, so I'm reading and writing to both, using pandas and PsychoPG2. The second learning criteria, I used pandas to do my data analysis. The visualization component I accomplished through an interactive GUI created by using the PySimple GUI library. And finally, the 2 learning components for this project are the GUI with user input validation and the Postgres database. So for the live demonstration, we'll first go through the tables that I created. So the first table I created was the orders table, which shows off the order queue. So this is created by the code. And so it contains simple things like the order number, schedule date, product ID, quantity, and status. The second table that I created was the inventory database. And so the foundation for this table was a Kaggle CSV file that contained things like product ID and product name. There were some other parameters too that I removed because they weren't relevant. So from the lead time column on, I generated using Excel's random functions to generate reasonable approximations. The reorder quantity and reorder point is modified by the code, and so the logic for this is based off the QR model I learned from ISE 552. The current inventory and net requirements are updated dynamically in the code. Both databases are updated in real time. So now we'll execute the code. So the GUI will bring us to the directory screen. And so for the 3 windows, I converted images to buttons. And so the 3 windows are the order status, the inventory, and the scheduling analysis. So when you click on the first one to create an order, so this just shows off the order queue that I showed earlier. And so you can either complete an order or create an order. So I'm going to create a fake order using a bad product ID to show off the input filtering. So it won't let you do that. I won't go through every single filter, but the user is protected. So next we'll go to the directory and show off the inventory database. So this again just shows off the different parameters that I showed from the database. You can add a part, and again, user is protected if you submit something that's formatted incorrectly or blank. Next we'll go back to the scheduling analysis. And again, this just shows all of the different parts that will require an order because of demand. So we'll go through and we'll create an order for 62856. We'll create this order. It'll let you know the order was created. We'll go to the order status. You can see that the order was created. We'll go through here. We'll complete the order. I'll tell you the order was created. Go back to the inventory. So you can see that, yes, indeed, the order was completed, inventory updated, net requirements are updated. And finally, we'll go to the scheduling analysis, and it's now off the list. So to verify that the table was updated, we'll go to the orders because it's the easiest to view. And we can see that indeed it was updated. There's the correct quantity and the status is marked as completed. So the database and the tables are all updated in real time. So this concludes my presentation for this project. Thank you for your time.